So today's lesson is going to focus around the 4 different types of functions and how we can reflect them, how we can transform them or shift them, and then some interpretation questions. So just before we get going, a quick reminder of the main algebraic functions. There's the straight line, there's the parabola, there's the hyperbola, and there's the exponential function. I want to know in the chat which one of these 4s is your favorite. So tell me in the chat which one of these 4s is your favorite. So you can kind of give me a happy face for the one that you like the most, and which is the one you dislike the most. So which one do you dislike the most? Tell me in the chat. I want to get a feel for the room's feelings about different types of algebraic functions. Tegovatso has said, I like the straight line. Puleng says, I like the parabola. Lutando likes the hyperbola. Kaklejo likes the hyperbola. Temi likes the straight line. Okay, straight line. We like the straight line. So often the straight line we talk about as mx plus c, or y equals, sometimes some textbooks have ax plus q. And then what's the one that you dislike the most? Okay. So exponential and hyperbola, okay. From Tegovatso, Kaklejo, parabola, exponential from Puleng, parabola. Okay, so before we kind of get going with the main things for today, I want us to just look at the standard forms of all these 4 algebraic functions that we're going to talk about. And what I want to ask you about initially is I want to ask a couple of questions about characteristics. So out of these 4, and you can name them 1, 2, 3, or 4, which ones have an axis of symmetry? So you've got to tell me, of these 4, like is it 1 and 4 and 5, which of these 4 has an axis of symmetry, or an A/S? Put your answers like number 1, number 3, number 4, whatever you think, the ones that have an axis of symmetry. So give me numbers. So like in the chat is, yeah, give me numbers. So I see number 3 is getting a lot of attention, and number 2 is getting a lot of attention, which is true. Okay. So if you think about the parabola that you guys normally look at is like something like this, and the axis of symmetry is halfway between. Okay, so it cuts it in half there. If you're dealing with the hyperbola, depending on what shape you have, you actually have 2 axes of symmetry. So the one axis of symmetry is going to look like that, and the other one is going to look like that. Okay, so axis of symmetry, 2 and 3 are the graphs that have axes of symmetry. So well done on that. Now, I want to know, of these graphs, which of them have asymptotes? So asymptotes, which of these graphs, 1, 2, 3, or 4, have asymptotes? Keep it coming, everyone. I see a lot of love for 3s. But Annie has snuck in a 4. Now that's a debatable point. Who agrees with Annie? Who would put a 4 in there? The 3 is correct. Yep. 3 definitely. Oratiwe agrees with Annie. And you know what? You guys are correct. Both 3 and 4 have asymptotes. So if you think of the hyperbola is kind of easy because it actually has 2 asymptotes. It has the asymptote, kind of the vertical one, and it also has the horizontal one. The line gets closer and closer, but never gets there to both the blue and the yellow. So those are the asymptotes for the hyperbola. But for the exponential, there isn't 2 asymptotes. But if, for example, we had an exponential that looked like that, then the asymptote would just be the horizontal one here. And so that's why 4 also has an asymptote. Okay, we're almost done with the revision. So we know which ones have axis of symmetry. We know which ones have asymptotes. I want to know, what does the letter P, which seems to pop up in pretty much all of these, okay, maybe not in the straight line, what does the letter P do in all of these functions? And I'd love someone to either put it in the chat or raise their hand and tell me, what does the letter P do to the function that you start out in life as? Who would like to share some knowledge with the team? Tabiso has put something in the chat. Who else? Anyone agree with that? Disagree? Move up or down? Horizontal shift? Horizontal shift. Okay, a lot of people are saying horizontal shift. And it turns out that the plus P has, or the P value does shift the graph left and right. So it moves it left and right. However, there's something quite sneaky about the horizontal shift. I would like someone to tell me what's sneaky about the horizontal shift, or about the plus, the P value that we sometimes see happening. We've come across this before. I just want someone to let me know what makes it sneaky. Okay, Mbasa has said horizontal. Tagavatso, let's go to you. Tagavatso, what do you think is sneaky? Can you remember the sneakiness?
I think that with P, we always, when we plot on the graph, we use the inverse sign.
Okay, so give me an example. If it was x plus 2, if P was 2, for example, like if it was here, and this had, instead of all this, it had x plus 2, what would the plus 2 do to that graph?
It would shift the graph to the left because we were going to change it to -2.
Okay, perfect. Yes. So because when you see the plus 2, you automatically think go to the right, but actually the horizontal shift moves to the left in this case. And Tabiso says it's counterintuitive. Exactly. That's exactly the word I would use. So just remember the horizontal one is a bit sneaky. Whenever you see a plus value next to the x, it kind of works the opposite way you would expect. Okay, one more question. What about the q value? What does the q value do in all of these functions? Also does it here as well. Yeah, so the q value is nice and easy. It's just the vertical shift. Yes, perfect. Okay, it shifts the graph up or down. You guys have got it. Okay, Conke, you agree. Fantastic. All right, you guys are ready for the main event. So you've done a bit of a revision of the basics of these different types of functions. So let's do some application. So what we have here is we have what looks to me like a parabola. And then we have G, which looks to me like a hyperbola. Now, I want you to reflect. So we're going to do A together. We have to reflect it over the x-axis. We have to take F and reflect it over the x-axis. Now, before we do that, I want someone to put in the chat, what is the rule for reflecting over the x-axis? So if you reflect over x-axis, what do you have to do in order to get F to reflect over the x-axis? Who can remember that from a previous lesson, or would you prefer me to tell you? So you're starting with this graph F, and we have to get a new equation if it's reflected over the x-axis. Who has any ideas? So you're starting out with this graph, and I need to reflect it over the x-axis. Okay, I'm not seeing a lot of information in the chat yet or any hands. Now here's the rule to reflect over the x. Oh, Tagavatso, there we go. What do you think we need to do?
So if you change the sign in front of y, you reflect over the x-axis.
Yep. You change the sign in front of the y, or you can even write change the y, or change the sign in front of y. And so what we're going to do is y is going to become minus y equals 4x squared plus 5x plus 1, and that will reflect the original graph. But what do we have to do now that we've changed the sign in front of the y in order to get the final graph in standard form? Who feels like they know? Because you're right, Tagavatso has given us the answer. You change the sign in front of the y if you want to reflect over the x-axis. But now to finish this, what do I need to do? Who has any ideas? It's almost like I want to get this y by itself again. Divide by -1. Yes, Ayanda, you could divide by -1, or you could times by -1. So it'll have the same effect. So if you divide the side by -1 or times it by -1, that becomes positive y. But now you must do the same here. And so you're going to get that. And so when you reflect that original parabola over the x-axis, okay, you are going to get that equation over there. Give me a thumbs up if you understand this idea of reflecting and then changing the sign in front of the opposite variable. Give me a thumbs down if it's a bit confusing to you. Okay. Now, I want you to try and do B all by yourself. So you've given, I want to reflect the g of x about the x-axis. And I want to see if you can figure out what you need to do. I'll give you some time to apply that idea. Okay. So Ayanda has asked, does this mean X has to be negative? So the rule that I seem to follow before was I wrote out G and I just made that a Y. And then I said, in order to reflect over the X-axis, I changed the sign in front of the Y. And so I made the Y become negative Y. But now I need to find a way to get rid of this negative Y. So what do I think I'm going to do? Put your hand up or pop it in the chat if you think you know what we have to do next to get this into standard form. So Mbali and Zanele have said there's a -2, and I think I know what they're doing. They're saying, look, if I multiply this side by -1, I get Y. If I multiply this side, I've actually got two things I have to multiply by -1. And so I'm going to get -2 over X plus 5. But then the sneaky bit is I can't just apply -1 to this. I also have to apply it to that. And then I'm going to get that. And so that's one way of writing well, that is the way of writing the hyperbola when it's been transformed. Give me a thumbs up if you understand why this is the reflected graph of G. Just want to make sure you're okay with that. Give me a thumbs down if you don't understand. It's important that everyone votes, that it's not just a case of, we do want to make sure I'm getting a good sense of the class's feeling about this. Okay. So before we move on to some more questions, I want you to just have a look at this little fun drawing I did down here. And what I'm showing you is if we think of the very first thing that we did when we were reflecting today, right? So when we looked at y equals 4x squared plus 5x plus 1, approximately, that would be this red graph over here. So what happens is you can see this is a happy parabola. When I reflected it over the x-axis, can you see I've got the green one down here? And again, I haven't drawn it perfectly, but you can see it's been flipped over this line over here, or reflected. And you can see it's now facing down, but it's going through the same x-intercepts. And so that's an example of reflecting over the x-axis with the parabola. With the hyperbola, it will look slightly different, but you don't need to worry because the algebraic method is pretty straightforward. Okay, Oratiwe, what is your question?
Evening,
Hello.
sir.
How's it going?
Fine, thanks, and you?
Very good. What can I do for you?
So I just wanted to find out that negative, does it affect the entire fraction or just the two only?
Lovely question. Such a good question. So lots of students are wondering about this. And what I want to suggest is that what happened in this question was I multiplied both sides by -1. Okay, so it's almost like I put this in a bracket and this in a bracket, and both sides got multiplied by -1. But -1 can actually be written as -1 over 1.
Oh, okay.
And then so what happens then is over here, this becomes y. The 1 goes to the bottom, it doesn't change anything.
Yes.
But the -1 goes to the top and gives you that. But then also I need to apply it here, and that's where I get the +6.
Okay. Thank you very much, sir.
Pleasure, pleasure, pleasure. Okay, so what I want next is I want everyone to try and do C and D. Now notice the axis that you were reflecting over is a bit different this time. But I want to give you some time by yourself to try and do that now. So C and D are for the students of the class. And once you've had a bit of time, pop your answer in the chat. What do you think is going to be a little bit different now that you, maybe somebody can put in the chat, how do we reflect something over the y-axis? It's a different axis this time. I'm just showing you what it looks like if you reflect a point over the y-axis. You can see the x value will change if you're reflecting over the y-axis. Now think about what algebra you can use to help you with this. So remember, if you are reflecting over the y-axis, you need to change the sign in front of the x, but the x is actually in a bit of a bracket here. So you're going to get 4 minus x squared plus 5 times minus x plus 1. And that's the x over here is going to change. So what do we think our final answer is going to be for f, for reflecting it over the y-axis? What do we think it's going to be? Give you a bit more time. Well, I think minus x squared just ends up being 4x squared. 5 times minus x gives me minus 5x, and then plus 1. Okay. See if you can do D. So we've just done C. See if you can do D, reflecting the g of x over the y-axis. You can do it. So what, reflecting over the y-axis. So I think I should change the sign in front of my x. Y is 4 positive. Okay, good question, Mbali and Zanele. So going back to f, if you think of what this means 4 times minus x times minus x. So that bit there means that. But minus times a minus is a plus. And so that's why it's 4x squared. Okay, so I hope that helps. Now, as we go to G, we have this one, and this is correct. So I've changed the x to be a minus x, but now sometimes this is correct, but sometimes they like to write it with a positive x value. So there's a little trick that you can do, and I'm gonna show it to you, and I just want you to be aware of it. So this is fine, this is correct. But if I multiplied the top and bottom by -1, just see what would happen at this stage. So I multiply the top, I get -2. On the bottom, if I multiply by -1, I'm just going to have, well, let me show you both. You can ask me, like, why am I doing this? But you'll understand in a moment. So all I've done is I've multiplied the top and bottom by -1. And what happens if you do that is -1 times 2 is -2, and -1 times -x is x, and -1 times +5 is -5. And so there's two ways you could have written this answer. You could write the reflection of the y-axis as this, or you could have also written it as that. They are the same thing, just different ways. And all I did was multiply the top and bottom by -1 to get that. Now that is a bit tricky, but yeah, I think it was important that I just show you that. Okay, time for a break. So I want everyone to turn their cameras on, and we are going to stand up, and we are going to get some fresh air and let our brains take a little break. So turn on those cameras. Oh, I can feel my legs.
Please turn on your cameras, guys. Let's see your lovely faces.
Do this. Come on. Stand up. And let's just shake our arms a little bit. Maybe you've been sitting in front of the TV all day. Maybe I don't know what you've been doing, but just shake out your arms and shake out your legs. Make sure you really do give them a shake, a proper shake. And maybe this one. Okay, and then let's just roll our shoulders back a little bit. Look out in front of you. Then roll your shoulders forward. That feels nice. Then grab your opposite shoulder. Stretch that out. Oh, that feels nice. And then opposite shoulder. Okay. Oh, lots of clicks. And then let's do that little one where we kind of just move, we rotate. So a little bit to start with. So maybe like, and then as your back loosens up, you can do this. And you should feel that you're slowly able to twist further and further. Don't hurt yourself, but just, and then let us do some high heart rate. So let's go with jumping jacks, because you just can't beat jumping jacks. They are just the winner. So clear some space. We're going to do 20. We're going to start in 3, 2, 1. Let's go. 2, 3, 5, 6, 7, 8, 9, 10. Halfway. 12, 13, 14, 15, 16, 17, 19, and 20. Here we go. And let's go. Let's just do the red one, and if someone's feeling the blue one, we can do that too. Who can solve the Maths 24 puzzle for today? So you can either do the red one or you can do the blue one. Close, Rye. 5 times 3 plus 5 is 20. Oh, you're right, but then you get 4. So I'm not sure if I'm saying it right, if it's Ray or Ru, but 5 times 3 plus 5 is 20, plus 4 is 24. Or Benjamin, 5 times 5 is 25, minus 4 is 21, plus 3 is 24. 5 times 5, yeah, Conke also, I agree. And then 5 times, yeah, I agree. Okay, anyone, can anyone do the blue one? The red one has been claimed. Philippiwa, I agree. That's what I see on in the chat. So for the blue one, 5 times 2 plus 7 plus 7. Yes, Benjamin, I think you have got it there. Well done.
Nicely done, guys.
We took that down, chop, chop. And Kechleko agrees, exactly the same thing. So the answer for this is 5 times 2 is 10, plus 7 plus 7. Well done. Okay, let's go back to the main thing for today. So now, instead of doing reflections over the axes, we're going to do shifts or transformations. So, well, I suppose they're both transformations, but yeah, these are going to be shifts left or right or up and down. So I want you to just have a go. I'm not expecting you to get it right, but the question is, if f of x is shifted 1 unit to the right and 6 units up, what is the new equation of f of x? And I'll give you a bit of time. Just think about what I've spoken about today, and then I will give you some help in a little bit of time. But do the highlighted in yellow one for me while I clean the board. You've got the original equation. Now, what do you think I'm going to need to do in order to accomplish this 1 unit to the right and 6 units up? Who wants to give me a hint? Who wants to come online and tell me what they think? Or maybe put it in the chat. What do you think we should do? Maybe deal with the 2 parts separately. Maybe somebody knows what to do with this one or to do with this one. Anybody have any ideas or tips? I'm going to start with this one first if nobody has any ideas about. So if I want to move the graph 6 units up, how would I do that in algebra referring to this bit here? I think I should just add a plus 6. And that will take care of that. Give me a thumbs up if that makes sense to you. That's moving it 6 units up should just be a plus 6. Okay. Now, moving it 1 unit to the right, so 1 unit to the right, Remember, though, this is a horizontal shift. And when we are shifting to horizontally, you do the opposite thing. And so whatever was x before, this, in order to go 1 unit to the right, this has to be x minus 1. So take a moment to think about, if I want to go 1 unit to the right, or plus 1 unit to the right, my formula actually has to be, or my change has to be to x minus 1. And now, if I want to then take both these changes and work with them, what am I going to do? Well, I'm going to have to multiply out, because this is x minus 1 times x minus 1. This bit is a bit easier. So I go 5x minus 6. This is going to be plus 7. And then here, so I get x squared minus x plus 1 plus 5x, and then minus 6 plus 7 is plus 1. And then for here, we're going to get 4x squared minus 2x plus 1. Now, I'm still not done, but I'd like to give you a chance to get me my final equation. What do you think my final equation is going to be in standard form for this one? So I'm not done yet. I still need to, it's not in standard form. See if you can work out what the who feels like they know the answer, they can put it in the chat. I'm thinking this 4 needs to be distributed out. So that's one part of it. Oh, wait, I'm making a silly mistake here. What's my final standard form going to look like? Feels like it's definitely going to be a 4x squared. And then I've got minus 8x plus 5x, which should be minus 3x. And then plus 5. Give me a thumbs up if you followed what I did there. Give me a thumbs down if you felt a bit lost. I think the hard part was understanding why this needed to be here. And then the other hard part was multiplying out correctly. Okay, so if you don't quite get it yet, don't worry. You're going to have a chance to practice this now. I want everyone to try and do the thing in green. So this is referring to g of x, and it's saying shifted 4 units left and 2 units up. And I want to see, can you do that? And then we'll keep going with this. Then we'll see how it goes. I can see it's this, yeah, there's 50-50 in terms of understanding, not understanding. So let's all give F a go, the one in green. And then I'll leave this other thing up on the board just so you can see. So it's 4 units to the left and 2 units up. And we're dealing with this hyperbola that looks like this. What do you think we need to do? Maybe handle each part first. Maybe handle this bit first, and then you can do this bit next. And I'll give you some time before the answers, before you put your answers in there. Mbasa has asked, how did we go from 7 to 1? Mbasa, if you look at the thing here, there was a -6. Ooh, there's actually a mistake in this because this can't be minus. This should be -5. My apologies. So this should be -5, and -5 plus 7 should be +2. Thank you, Mbasa. That was a great question. And this should be +2. And then over here, this should be +2. And so this should be +6. Thank you for catching that, Mbasa. That was spot on. You see how quickly these little mistakes can creep in if we're not careful. 5 stars for Mbasa. Okay, now back to this one over here. Are we seeing any answers? Well, let's do the first one, which is 2 units up. I think for 2 units up, I'm just going to add a +2. And that's going to deal with that. But what's going to happen to deal with this part here? What do you think I'm going to have to do to move 4 units to the left? I think that in order to move 4 units to the left, so 4 to the left, I'm going to have to add 4 to x, or add 4 to whatever x is at the moment. Well, let me just change this back. So if I'm moving to the left, left is normally negative, so then I have to add 4 to x to help me. So now, if I look at this thing here, okay, so let's go in there. We've got x, and x is going to become x plus 4, but there's also a +5 already. And then the -6 plus 2 is just going to become -4. But now what is going to happen beneath that? What is this bit going to end up being? So just to show you what I did, to move 4 units to the left, I added 4 to x, or I made x plus 4. So that's this bit here. But now there's still a +5 there. So then it's going to become y equals 2 over x plus 9 minus 4. Give me a thumbs up if that makes sense to you. Give me a thumbs down if that doesn't make sense to you. Just want to get a feel for what is going on. Okay, now we've still got some time left. So I want us to do G, and I also want us to do H. So the 2 ones I've just highlighted in yellow, I want you to try and work out the new equation if you do those 2 ones in yellow while I clean up my board, and then I think we're pretty close for being done for tonight. What is the new equation for this one going to be? Who feels like they have some knowledge to share, some wisdom to bring to the classroom? So 9 units down. If I want to move everything down by 9, what is the algebra that's going to help me do that? Yes, Annie, I think I agree. Comke seems to agree as well. If I put a big -9 here, that will move everything down. And so my final answer should be -8. And that will shift everything down by 9 units. Okay, what about H? So H, I'm given the graph, the hyperbola, and now I need to shift everything left by 1 and down by 2. What do we need to do for that? So 2 units down and 1 unit left, and we're referring to the g of x, which is the hyperbola. So I guess the easy part is the 2 units down would just be a -2 for the q value. The little bit harder part is the x, but remember the x works a bit weirdly. If I want to go 1 unit to the left is normally the negative direction. So where there was an x, I'm going to go x plus 1 to move everything to the left. But I mustn't forget there's a +5 hanging around. And so what is my final transformed function going to be? It's going to be that 2 over x plus 6 minus 8. Okay, so what have we learned today? Well, we started the lesson by going over the 4 main types of algebraic functions. We spoke about how some of them have asymptotes and some of them have axes of symmetry, and we identified them. We then spoke about how can we reflect functions over the x-axis and y-axis, and we did some examples with parabolas and hyperbolas, but these rules will also work for straight lines and exponentials. They don't just work for these two, they work for all algebraic functions. And then in the second half of the lesson today, we learned how to shift graphs left and right or up and down.